Why is our so-called smart technology still so dumb? We live surrounded by devices that predict our preferences and finish our sentences, yet they crash, freeze, or make laughably simple mistakes. Our apps forget what we need, our networks overload, and our systems break down under pressure. For something we call intelligent, it sure doesn't act very alive. So maybe the question isn't how to make machines smarter. Maybe it is how to make them more organic. There's a new field rising quietly inside computer science called organic computing. And no, it's not about growing computers out of living tissue. It's about designing digital systems that behave like ecosystem systems that can heal, adapt, and protect themselves the way nature does. For decades, we've tried to control every single line of code, every possible scenario. But nature doesn't work that way. When a forest catches fire, it doesn't wait for a central command to tell it how to respond. It reacts dynamically, locally, through millions of small feedback loops. And somehow, over time, it finds balance again. That's the philosophy behind organic computing. Instead of building rigid systems that break under stress, we design flexible, self-organizing ones. We stop writing code that simply executes instructions and start designing code that learns how to live. Now, it's easy to confuse this with something called biocomputing or organoid intelligence, which use actual living cells to perform calculations. But organic computing is completely different. It's about making digital systems behave biologically, giving them the patterns, adaptability, and resilience that life itself evolved over billions of years. The heart of it all is a beautiful concept called emergence. Emergence is when simple things, following simple rules, create complex, intelligent behavior. No central brain, no master plan, just local interactions that add up to global wisdom. You see it in a flock of birds swirling together in the sky. Each bird follows just 3 simple rules. Don't collide with your neighbors, match their direction, and stay close to the group. That's it. From that simplicity, a breathtaking dance emerges, one that no single bird could ever choreograph. Organic computing borrows that same idea. Instead of one controller telling every part of a system what to do, we give each part a few local rules and let intelligence emerge. Think about how we build systems today. Most of our technology is brittle. One server goes down, and the entire app collapses. A single bug can cause chaos for millions. We keep patching and adding layers, but each patch makes the system heavier and more fragile. Organic computing flips the script. It says, stop micromanaging. Let the system handle itself. Imagine a network that senses damage and reroutes automatically. A power grid that balances its own load in real time. A cybersecurity system that detects and fights threats like an immune system, identifying intruders, isolating them, and remembering how to fight them next time. These aren't distant dreams. Prototypes already exist in research labs and some industrial systems. It's happening quietly beneath the surface. Organic computing works because it gives every component awareness, not consciousness, but awareness of its context. Each part monitors its own state, observes its neighbors, and adjusts based on simple local information. When every part does this together, the result is astonishing. The whole system becomes adaptive, almost alive, not intelligent like humans, but self-sustaining and self-correcting. A network built this way doesn't crash when one node fails. It reorganizes. Power grid doesn't wait for commands. It balances itself. These are the digital equivalents of healing, metabolism, and immunity. But here's the catch, and it's a big one. When systems start to behave organically, we lose the illusion of total control. We can't predict every outcome because the system develops its own patterns. We move from being strict engineers to becoming gardeners. That's the real shift in perspective. We stop commanding machines like obedient servants and start cultivating them like ecosystems. We shape conditions, not actions. We nurture growth, not micromanage behavior. It's a humbling change, but it's also incredibly freeing. Because in nature, control is an illusion and resilience is the real power. Every organic computing system, at its core, follows a rhythm of 4 steps. First, sensing. Each part observes its environment, what's happening nearby, what's changing. Second, local rules. Each unit decides on small actions based on simple, predefined principles. Third, coordination. The parts talk to each other quickly and locally, sharing just enough information to stay in sync. And finally, adaptation. Over time, the system learns. It tweaks parameters and gradually improves its responses. Together, these 4 steps create something remarkable: a digital organism. A system that doesn't just run, it evolves. Organic computing shines in complex, messy environments where central control fails. Think of global logistics, smart grids, or swarms of drones, anywhere conditions change too fast for a human or a top-down algorithm to keep up. But it's not a magic bullet. There are areas where you still need absolute precision, like in spacecraft navigation or surgery robots, where unpredictability is not an option. Organic behavior works best where resilience matters more than perfection. And yes, there are real risks. When local rules combine in unpredictable ways, strange patterns can emerge, behaviors no one planned for. It can be hard to explain why a system did something. Who is responsible when an autonomous system rewrites its own parameters to solve a problem in a way humans didn't anticipate? That's why guardrails matter. We can give organic systems freedom, but within boundaries, just like life on Earth evolves inside physical laws. We build safety layers, simulation sandboxes to test behaviors, kill switch mechanisms to reset systems, and hard rules that can't be broken. We also build new kinds of monitoring tools that study the whole ecosystem's health. That's how we keep the benefits of emergence without losing our grip on safety. So what could this look like in our everyday lives? Imagine your phone network during a huge concert. Everyone's streaming and calling normally. The system would choke. But in an organic network, the towers talk to each other. They negotiate load and share capacity on the fly. No one's in charge, and yet it just works. Or picture a city power grid that senses a storm rolling in. As wind turbines slow and demand spikes, the grid shifts automatically, borrowing power from neighborhoods with surplus, rebalancing without a single engineer typing a command. When the storm passes, it stabilizes again. No chaos, no blackouts. That's the promise of organic computing. Systems that survive the unexpected because they rebuilt to live in the unexpected. If you found this look into the future of technology fascinating, please consider liking this video and subscribing for more deep dives into the science that's shaping our world. Thanks for watching.